I'm Tal Liron. I am also self-employed, and you should hire me if you need me to save you from yourselves. My specialization is resurrecting half-dead startups from their terrible messes. I can do that. I used to work here at CrowdSpring too. I was fired after an incident where, oh, hi Mom. Hi Mom. Yeah, but am I behind the pole? All right. Okay. So I will today. I've presented at ChiPy a few times in the past on all these various issues. I'm strongly involved in the Jython community and a big JVM believer, but also quite agnostic and love CPython where I can. I just completed, as I told you on the mailing list, a pretty large music player project based on CPython and a lot of other libraries. And maybe in future ChiPy meetings, I'll talk about some more aspects of it. What I want to talk to you about today is something very exciting, I think, and very new. Recent developments in the GObject library that make it really, really easy and elegant to integrate binary libraries into Python and other languages as well. It's the kind of cusp of a history of a bunch of different technologies coming together. The first part of my talk, I'm actually going to delve into the C code. So those of weak constitution, maybe hold on to a friend. The second part of the talk, I'm going to go into some of the history of this and some of the implications for the present and the future of these technologies, and also, as promised, a little bit of a comparison to SWIG. Shall we start? Okay. All right. What do we see here? A really simple Python program. Ignore for a moment that import, but look at what it does. It creates a logger class, gives it a name, and an instance of a logger class, and then logs a few statements. There's a log increment there that I'll explain in a second. I'll show you how it looks when this application runs. So here I am running it. Prints out our logging statements. You can see every statement has a running number, and that increment that I did was just a call to kind of increment the number without actually logging anything. Not a really interesting library, but it was the best and simplest idea I could have come up with for the example. One small thing to note here is that you notice when I started the test.py, I set up two environment variables, the LD library path and the GI typelet path. Usually you don't have to do that. These are part of the loading system for binary objects. If you installed your binary code in the operating system's usual place, it will just load it. Same goes for the typelet. But since I built this in my own little directory here, I had to set these variables explicitly. Not too exciting, right? But let's look at the C code in which this was written. How many people here are familiar with GObject or wrote code in GObject? Okay, 2, 3-ish. Actually, so I'm going to show you some of the C code. It's going to be somewhat painful because it's very verbose. I won't get into too much detail into it because this is about Python, not C. But it's very illustrative of what kind of GObject looks like, some of the problems of it, and how they're nicely solved with some solutions we'll see. So a very simple GObject library. This is the header file. I called it logging logger.h. Logging is the name of my library. Logger is the name of the class in the library. This is a convention that's actually used for one of the tools we'll look at later. This is actually the struct that defines the class itself. It's data. So we have one GObject instance here that it's called parent instance. The reason that exists here is that we're inheriting from GObject. All the classes in the system inherit from the base GObject. So that data there is just a reserved space for all the data from the parent class. So that's kind of a standard of inheritance. Whenever you inherit, you have to make sure and see that you actually have space for that data. Then I have a name, a pointer, and that is the name of the logger. That's kind of printed out, and in the Python code, right up here, that's the name I gave it originally. Oops. And then we have something called private data, which is hidden here. It's just a pointer. We don't know how it looks like, and that gives us some space to put our own data that we want to keep opaque and not actually expose to users of the library, but we can use it internally, and it is carried around with the class data. I'll show you how that works too. Then, annoyingly too, we actually have to define the type of the class as well. So the class actually stores information, things like virtual methods and things like that. If you've ever programmed in C++, you know that the language handles that all for you. But in the case of C, we have to actually explicitly create the class for the type. So by convention, again, it's called logging logger class. And again, for the inheritance, I actually have a parent class here to take the data from the inherited type. And there I have my virtual method, which is the log method, which is a function pointer defined in C. Then I have a bunch of all this boilerplate stuff that a bunch of defines that use part of the GObject system to help me access types and things like that to make it less verbose later on. So the extra verbosity at this point means that later on it's easier to use the library. All right, this is just the header file. Let's actually look at the C code. So the C code, first thing I do is I actually define my struct for the private data. And it has that counter, that incrementing counter that we use for the log messages. Then we do this function here, which takes care of, well, two functions here that take care of getting and setting properties. So in GObject, there's a way each object has properties, right? In this case, our property is the name, right, the logger name. And you'll see it's pretty verbose here. Sorry, I keep moving behind the, all right. He's part of the presentation. You see it's quite verbose. I have to have this like enum where I give constants to all of the properties that I have for the object. And then there's this get property that accepts this something called, you can see on top there, a G value. So this is like a generic, GObject gives you kind of a generic type that you can, the nice thing about it that it lets you, internally it can cast between different types, so it can convert between ints and strings and things like that for you. Why is that a nice thing to keep it in the library and not let users of the library take care of it is that it's very consistent. So, if Python handles conversions of strings to longs in one way and Ruby does it another way, both if they use this library, their values will work the same way because the conversion actually happens inside the library. So that's a nice thing that is included inside GObject. But yeah, it's quite verbose. You see we have to take care of the memory. You have to do a gfree for the string that we get in and make sure that we dupe it again. It's C. You have to manage your memory. Then we have this other part of the boilerplate code, which is class init. So this, when our type information, for the first time when we create an instance, GObject actually creates kind of a tree of all the classes that it has, its runtime type information. And it calls this only once when it first loads the class. So what we're doing here, we're setting up the property get and set methods. We are also setting, you see that class arrow log equals logging logger log default. That puts the virtual method, right, the very first kind of default. So if class is inherit logger, let's say we create a logger object that logs to a Redis database or something like that on top of it. So it would override, right, this virtual method, and then our instances would call it appropriately. So a lot of work to do stuff that C++ say would do for us. And then we actually have an init for the instance itself, which sets count to 0. And I'll note here too that GObject, the init is not the constructor. There are constructors as well that you can define. Init is called before the constructors, and it's just to make sure that the instance is ready. And then there are constructors that you can define. There's a lot of boilerplate code for that, where you can define different kinds of constructors and do different things. In this example, I didn't use constructors because I wanted to keep things simpler, and you can see they're already pretty complicated. Then we actually have a few functions that do the work. So there's the function that actually logs. So you'll see it gets an instant to self. So this kind of reminds you of one of the complaints about Python, that you have to pass self to every method. So of course in C you have to do that as well. And there's some assertions here, part of the GObject system, to make sure that we actually got an object of the type we're expecting, because otherwise we just have a pointer, right? We can't know for sure what it is. And there's my increment method, and then the virtual method that actually prints the logging message with a gprint there. Very, very simple. So, okay, boilerplate code to make the library, right? I want to show you now how it's actually built, because that will give you kind of an idea of how all the parts fit together. I should mention too that all this code is available on GitHub, and it's very valuable. A lot of the stuff I'm going to show you right now in the build script is really, really new. I mean, I'm talking about the last 6 months, a lot of these pieces came together. It was pretty hard for me to piece them together from the documentation out there, and I'm on the mailing list, I troll them, and I see a lot of people having problems. So this, I think, is the first kind of real example that does the complete route connecting C to Python. Okay, so this is just a bash script, but I'll get here to the building the C library. So what I'm doing first, I'm using GCC to compile. Pretty straightforward. Is anybody familiar with GCC, auto tools, and all that jazz? Yeah, good times. So on purpose here, I didn't use dmake or make or any kind of tool, because I really wanted to show you how the tools are called very, very directly, rather than having an automatic configuration around it. So first thing we're doing, we're compiling the C code. Using GCC, I create a logging.o, okay, the object code compiled binary. Then I'm calling the linker. Remember this from computer science classes, compilation, linking? I'm creating a shared library version, right, of that compiled object code. And you'll notice, too, I'm including the GObject library in it. I mean, that's the only requirement for what I have. GObject, in turn, requires also glib. It's included in that, and I'll explain the relationship a bit later. Okay. So from that, what I have is a liblogging.so, a shared object library, which is a binary library. Any C library out there, anybody who has a binary interface can interface with my code, as long as they have the header files, right? And they know what to do with the data, and they can use the library as it is. But now I want to use it in Python. So next step. You'll see a lot of notes here. I'm not going to go through them, but that's part of the pain points that I had in making this all work. So again, very, very valuable for you to have these if you want to do this yourself. The next thing I'm doing is I'm running a tool called the GIR scanner. This is a tool that comes with a GObject system. And what it does is this. It goes over my C code and the header files and generates a GIR from it. And a GIR is a XML file that describes basically all of my types and my functions and methods. It is kind of like an IDL if you work with other similar kinds of systems. And I'm going to take a moment to stop and show you how it looks. So this was generated, it says above, it was generated automatically for me. And it's a pretty verbose XML file, but you know, it was all automatically made. And it includes all the types, what they inherit, which shared library I'm using, which versions of the dependencies for GObject, glib, Another interesting thing, you'll notice here and there are doc elements. So it also includes documentation. I'll go back to the C code, or maybe it's in the header. Yeah. What can I do?
Can you zoom in? I'm seeing like little blobs here.
Yeah. Let me try to do that. I'm using gedit. Yeah, I tried that. That's search, apparently. Fonts. All right. There we go. Whoa. All right. Yes. Python. All right. So this is much bigger. So you see a C comment here, but it's a special comment in that it has an extra star on the top. You might recognize that from working with Java or C#. That's kind of a signifier that this isn't a standard comment. This is actually a documentation intended for some sort of parser. So in this case, the GIR scanner knows how to read these. And
is this like a fifth different C documentation format? Like you've got oxygen and stuff?
No. This is unique to the GObject system, of course. But it's pretty compatible with a lot of the other ones. And the really nice thing is that there are excellent documentation generators out of this. So if you have the C library, if you go right now, if you try to program with GTK or GStream or any of these GObject-based frameworks, this is what they use right now to generate their documentation. I think it's fine, just as much as the other one. And of course, you have this XML file coming out, this GIR, so if you want to write your own documentation generator, it's just parse the XML. Yep.
G as in GNOME or G as in GNU?
It is, I'm going to get to that in part 2 when I talk about the history, because it's actually G as in GIMP. Okay? We're going to get to that. Okay, so this is kind of a long XML file. And, all right, I have all the methods, the virtual methods, their types, etc. The next stage, after I generated this GIR file, is running the GIR compiler. What the GIR compiler does, it takes that XML file and turns it into a binary typelib file, which is the one actually used by the library. So you can wonder, why do we need this extra intermediary format of the XML? Well, XML can be used by lots of different tools. So they wanted just to give another way out so that you wouldn't be locked into the binary format. But the typelib, that's a really simple step. It just takes that XML and turns it into typelib. Doesn't include the documentation in this case. It's just kind of the type information. So really, all you really need to do, if you go back to when I actually ran the code, right, I include the LD library path and the GI typelib path. All I really need is those two things, the binary shared object, which is a totally normal C binary. That's what I want to keep emphasize. It's a standard C ABI. This was C code that we were writing. Nothing really special about that. And then I include this extra typelib file, which is the new innovation. And then I can connect it into Python. So we'll go back to the Python example. And oops. So that first line, right, from gi.repository import logging, that's PyGObject. So the project itself is called PyGObject, but GI here stands for GObject introspection. And if you just import from GI repository, it already knows behind the scenes to look for the typelibs in all the known places, load them, and create the Python class tree on top of it. It's pretty smart. It caches everything, so it's very, very fast. But there you go. What could be more simple than that? So you see I have an instance of the class. The usability is very, very simple, right? Actually creating the C library wasn't so easy. One thing that I'm hoping that as this evolves is that actually the binary typelib would hopefully be included inside the shared library too, because having those two things seems kind of, the typelib is really, really tiny. I mean, we're talking about size of numerous bytes or Ks, but it's still two things that you have to deploy, and it would be nice if they would actually be included. But since this is all so new, this is still where we are right now. Any questions so far? You can dive in whenever. All right.
So if you use that in Ruby or
Right.
Just do GI,
Exactly. There are different versions of this for all the libraries, and I'm going to mention a few of them. They're actually shown here on the slide. It's actually supported on various JavaScript engines at this point. Scheme, Java, C#. Haskell has a very good binding for it. Perl, PHP, Lua. The really, really nice thing is just like PyGObject, once you implement it, you can connect to the entire GObject world. Any GObject library there, you would be able to immediately use without any specialized bindings. So, of course, it is the standard right now for GTK plus version 3 that just came out. So they actually deprecated all the old bindings for it. And from now on, they want you to use PyGObject for everything. And it works. I wrote my music player in GTK3, and of course, everything in the GNOME 3 desktop is written in this as well. Yeah.
So presumably in the future, I don't think it is right now with the current version of GStreamer, but like if GStreamer goes with their next iteration or whatever, you think that it basically will mean that you no longer import GStreamer itself into your Python code, you just import GObject introspect, and then if you have those C libraries out there, you can pull out the entire thing, or
Yeah.
you think it's still going to be...
Excellent example, because I'm also involved in that, and I opened a few bugs on the current version of GStreamer 0.10 they have supported typelibs, but there are numerous bugs in it because they use features of GObject that aren't 100% supported by PyGObject right now. There's something called mini objects that are kind of lightweight, and they don't really work well with the typelib system at this point. So GStreamer does work, but not work well enough that I could actually use it, but they're really interested in doing that. Actually, the entire GObject ecology right now, all these different software projects are working hard on migrating because the benefits are huge.
So it might be now, but in the future it could...
Absolutely, in the very near future. Actually, you can get the Git builds right now, and they actually do work well. But the release versions don't work too well with it. Until now, it was really, really hard. Well, not that hard, but it was somewhat hard to support a GObject library with bindings for all the different languages. There were a lot of tools that could help you. There was tools kind of similar to SWIG in that they would create. You could take like a GObject library and you give it some descriptors, and it would generate all the Python kind of scaffolding or Ruby scaffolding or whatever you need to call all the instances. So it wasn't too much work to create these bindings, but there were still, every one of these projects has a maintainer. Like, okay, the guy in charge of maintaining the GTK bindings for Python or the GStreamer bindings for Python. And the same thing for all the different languages. So it wasn't a lot of work, but it was still really dispersed in that some of these fell out of use. For example, I remember trying to create a project with Ruby GTK's bindings, and they were not well maintained, and it was just, it was not easy. But that problem disappears in just like one fell swoop right now, because this extra typelib information means that you no longer have to maintain all of these. And look at all these languages that are supported, and more will be supported in the future. So a GObject binary library, if you just, as it is, the GIR scanner creates the GIR for you. I mean, if you wrote good GObject code, it immediately works. It's kind of beautiful.
It also has the effect of centralizing your access to that system, right? Like in your music player, you're actually accessing the sound, and then also the windowing framework and so on.
Yeah, it means that you kind of have one system to work with everything, and then does it really matter if you're doing from GI repository import or from something else import? In the end, it's just Python code, and you just use it as it is. So that's the really nice thing, is that from a Python user's perspective, there's nothing really special about this. So this is the SWIG comparison slide. I promise you a comparison to SWIG to see who wins. It's not going to be about that. It's going to be about loving everybody, and everybody has their value. I'm actually a very big fan of SWIG, but I'm also a very, very big fan of GObject. And one of the first questions, and I kind of baited you on this before, was why not just use C++? Why go through that pain of like writing a C library with all that boilerplate code, this GObject library that handles it, where you can just use C++, it's a language designed for it, and then you can use SWIG that takes that C++ bindings and creates the Python stuff for you already. It supports a lot of other languages as well. It's a good question. And I'm going to try to make a defense of C here, which is tough, because C is not a beautiful language. But the advantages are enormous, I think. C code is the most portable code there is. Some would argue that, okay, C++ is just as portable right now. GCC, any platform that GCC runs and would also support C++. Are there people who disagree with this statement? Yes. Why? Which realm do you work in where that doesn't work?
I've worked in embedded stuff before. There is
Right.
C++ embedded.
Right. And if there is, it is not, unlike C, where you have a really set standard, ANSI C, the standards for C++ are moving targets. There are very different implementations of it. And probably hardest of all is that there is a standard C ABI. Any C compiler out there, even though it's a little bit different, will create a standard C ABI, which is the ABI that everybody uses. There is no standard C++ ABI, and there never has been. There is a standard ObjectiveC ABI, though, and I'll mention that a little bit later. So the problem is, if you write your code in C++, you are limiting your usability. You will not be available everywhere. And I'll give you, again, a concrete example of GStreamer. GStreamer is a really rich object-oriented framework for media. It's really awesome. I hope to give a presentation maybe in the future on it. But it runs on cell phones. It runs on all these vertical devices, MP3 players. Those environments, you have really quirky compilers and a lot of restrictions. But it is totally portable, and it runs there because it's written in C, and its only requirement is GObject, which is portable and CC. So you're golden. So that library can compile and run anywhere, and then it gets the full advantage that you can still use it from Python and Ruby. That's a kind of win-win situation. And then there's Vala, which I'm going to get to again. I'm promising you a lot of things I'll get to, but I will. Another nice thing about GObject specifically, it provides features that you don't get in C++. C++ does have runtime type information which you can enable. Again, it's not totally portable between different C++ versions, but GObject gives you much more. It gives you a real kind of dynamic typing system that you can actually do duck typing in your C code. I'll show you something quickly that I actually wrote that same code we did in Python. I wrote the C example of it. So this is actually C code using a GObject library, just to show you that this is entirely standard C. It looks a lot like the Python code, just like twice as long. You can see there's kind of the G value boilerplate to set up the values is pretty painful. You have to init it by the type and then set it, and then there are different kind of functions to okay, I want to set the property with a string, so blah, blah, blah. But then I just call the virtual functions that I want, and GObject takes care of everything else. So in fact, you can use these functions to do duck typing, which you can't do in C++, but you can do in C with GObject. So actually, you have C doing object-oriented better than C++ in this instance. Another nice feature that GObject gives you is two messaging features, signals and closures. This isn't object-oriented. It's not related, but it gives you the opportunity to kind of hook, catch certain signals, listen to them, broadcast them. It's a nice feature that's included in the framework itself. So any instance can register a few events. You can listen to them and get them back. Not something that you can't do in C++, but it's nice to have it already included. And a lot of tools make use of it too. So PyGObject already supports it. It's for free. And it also has reference counting. It does that for you as well. So again, not something you can't do elsewhere, but it's built into the system. How did we get here is really interesting, and I'll answer some of the questions that came out before. I really like this history because first it tells you, well, it's kind of distills the history of free software. And when I'm saying free software, I mean free software, not open source. Very important distinction that RMS constantly makes, valiantly so. And another really interesting story is that none of this was intentional. This all evolved very, very slowly. according to needs that first came out. So to get to this point where I could write C code and use it in Python in this manner, the original designers of this had no idea that this would ever happen, okay? Python was like a young child at the time. So where does it start? It starts in 1996. What is that, like 50 years ago? Something like that. We had the early attempts to create a free desktop were based for Unix systems. One of the most popular one was KDE. And it had a commitment to true free software with the GNU license. And a lot of people were very excited about it, except for one little hitch. It had a dependency on a widget kit created by a company called Trolltech called Qt. Now, by now, so many words were spilt over this particular issue. By now, Qt is actually, Trolltech has released the licenses in such a way that I don't think there are any issues with it anymore, although there are some lawyers that are still, Ross, you can take this cause up, I hope. But at the time, Qt was a real kind of thorn in the mission for free software. A lot of people were worried that this would hamper us later on. Another interesting thing happened in 1996, which was unrelated to the KDE desktop, and that was the release of GIMP, the most inappropriately named alternative to Photoshop ever. Yes, I apologize for them. What does it stand for? Yeah, GIMP is not, the GNU image manipulation program. Okay. The designer of GIMP, these were the early days of the X windowing system, people building really big software on top of it. And the standard then was Motif. Has anybody here ever worked with Motif?
Yes. The Citrix client for Linux up until not too long ago depended on it.
Absolutely right. I mean, it's still like absolutely important to maintain that decrepit piece of crap. But yes, it is a C library that provides you with widgets over X windows, things like text and basic menus and buttons. It is not object-oriented, which is, I have a lot of problems with object orientation, but widget systems is one of those places where it works very well. So it was very painful to work with it, and GIMP was a very, very large piece of software, very, very rich interface, and it was impossible to use. So what they did was create their own toolkit, which actually was not object-oriented at first, but that was GTK was released in version 0.6 of GIMP. That's when it came out. And it was like a really nice kind of alternative to Motif. But the next year is actually, I think, the critical moment for a lot of this. That was when a lot of these arguments about the Qt library were coming to fore. And a few kids from Mexico decided that they tried to argue as much as they could for the KDE project to remove the Qt requirement. It didn't work out. There were a few different camps involved, and they decided, okay, we just need to start from scratch. Building a desktop from scratch is not easy. There are a lot of widgets that you need. And they decided, they looked around and said, okay, where do we have true free GNU software out there that we can use? And that was the GTK, the toolkit that was devised for GIMP. That was the richest, had the best license. And actually, that year too, the really interesting thing that GTK Plus came out, which was the object-oriented version of GTK. And of course, nobody remembers the original GTK. We remember GTK Plus. So the GNOME desktop was born in Mexico. Two lead founders, I forget the name of the second one, but the first is Miguel de Icaza, who appears again. So 4 years later, Miguel is looking at the GNOME desktop and looking at the, it's based in C, because GIMP, of course, was written in C. And saying it's really, really hard to develop applications in C for the GNOME desktop. We're really limiting our ability to bring a lot of programmers in. KDE was written in C++, and people were much more excited about that. So Miguel actually took upon himself to create a new platform for developing GNOME applications in C using a lot of, GNOME applications, using GTK, and he took the .NET runtime and basically said this looks like a very good approach because it is managed code. I'll get to that in a later slide. And it's a very nice language. It kind of looks like C++, but it's actually much better. It has delegates. It has all these memory garbage collection inside. And that's when the Mono project was born, with not a little controversy, because a lot of people were worried about, it's an exact copy of C#. It runs ILR code, and there are a lot of worries about that too. And also, a lot of people worried about the notion of managed code too. I mean, why do you need this big virtual machine running? There are good reasons for that, bad reasons for that. Well, I wouldn't say bad reasons. Good reasons, but they're arguably problematic. It's 2002 that we really see the birth of GObject. So by now, GTK Plus is a very sophisticated widget system, and a lot of people are very interested in the kind of object-oriented underpinnings that made GTK Plus possible, and interested in using them in other projects, such as GStreamer, that have nothing to do with GTK. And it became clear that you really wanted to get that out of GTK so people could use that without even depending on anything graphical, right? 2006 Vala, which will be the next thing I'll show you, and 2008 Genie. Anybody heard of Genie? This is going to excite you. I'm so excited for you guys. Somebody has heard about it. Okay. Fast forward 2011, that's when GTK Plus 3 comes out, and with it, the PyGObject introspection that we're using right now. And that's kind of the last piece of the puzzle that really, I think, brought GObject to like a really usable, rich framework, which I hope you will start using, because now it's finally there. All right. Vala. Oops. Oh, wrong button. What am I doing? There we go. Yeah. No comment. All right. Look at this class. If you've ever programmed in C# before or Java, that's very, very familiar. You remember all that C code that I showed you early on? The Vala compiler takes this, and I'll show you what it creates. Oops. Oh, actually, I'll have to build it first. So my little build script, right. Okay. You see it ran the same example, and it worked exactly the same because this Vala code created C code that's pretty much equivalent to all that boilerplate stuff that I did before. Here it is, logging.c. Okay. You can see on the top, this is automatically generated by the Vala compiler. And it looks kind of similar to the code that I wrote by hand for the C example I showed you earlier. It actually has a bunch of other stuff here. You can see some of the, the compiler giving all these like temporary names for variables. So it's a little bit more verbose, of course, but pretty much does the same thing. So actually, if I show you the build script again, you can see it building the Vala library exactly the same way. It accepts the .vala file. And the nice thing about it, it can also automatically generate the GIR too, so I don't have to run the GIR scanner tool. Yes, quick question?
So since Vala is just generating C code, is it reasonable that you might have a larger C project that has a bunch of stuff written in C, but then you might write a few specific things in it in Vala, and then it can just convert those over to C?
Absolutely, absolutely. That's a very, very attractive, actually, system. And it's also very instructive, even if you don't intend to use Vala, just to look at the C code, because you can see some things are really hard to do in GObject, like all these virtual overridden methods and stuff like that. And you can just kind of experiment with Vala and just see the C code and copy and paste it into your own C code. It's kind of neat. But the Vala compiler already creates the C code in the background and then sends it to GCC, and eventually you get, with much, much less code, exactly the same result. What Wow. Okay. Why is my keyboard not happy with me?
Use the menu.
Yeah, I did something bad. Oh, there you go. All right. So a lot of comparisons first come to mind, and one of them is the comparison, of course, with mono. It seems to be awesome. It seems to have all the advantages that mono doesn't have. Right here we have, like, we take our Vala, we can write our code, instead of writing it in mono, let's write our application in Vala. And we end up having a true C binary that anybody can use. It doesn't require mono, it doesn't require any kind of runtime. And indeed what we're seeing right now is a lot of projects that used to use mono are actually rewriting themselves into Vala with not too much work actually, because if they didn't use too many of the standard libraries that come with mono, the code is almost identical. But then, users are much happier because they don't have to install mono to use it. But, here's my little defense I would still make of mono. The idea of managed code is a very good one, I think, for consumer applications, for consumer devices. Of course, it's the foundation of Android. It uses Dalvik, a JVM-based system that is very similar. And the huge advantages of managed code for consumer devices and environments are big. Security is all there. Version checking is all there. You guarantee a lot more robustness and stability with managed code. Microsoft has been trying to push it for a long time with making .NET the center of their user experience with mixed success. I think in Windows 8, I think might be a moment where we're going to see finally this first test to see if managed code works. In the free software world, I think there's been a movement away from it. And Vala is eaten up hungrily right now by people who want to develop applications and libraries that everybody can use without being hampered by mono. But I would encourage everybody to kind of take a step back and think of what we're actually losing by not having managed code. And I'm glad that Miguel is still working on mono, and that project is not going to die. I'm missing a slide here. Something happened to a slide, but the slide was a comparison of actually looking at Vala versus C++ and Objective-C. And I think that's an arena where Vala can be really exciting. If you need to develop a new binary application right now, if you want to choose between those three languages, Vala gives you a lot of the advantages that C++ has, but you get the standard C ABI, right? So you get the total portability. You can write Vala code and run it on a toaster, right, that only has a C compiler. You can't really do that with C++. And you guarantee longevity to your project too, because it'll run on toasters of the future, right? Or rice makers, which C++ code, you don't really know how long it's going to survive, because C++ is a moving target. Already there's a lot of debate over the next true version of C++. Another nice thing that Vala gives you all these freebies that C++ are kind of hard to do. For example, the messaging stuff, the signals and closures, and then the runtime type information. You can do duck typing in Vala, which you cannot do in C++. So that's pretty cool. Objective-C is kind of interesting. Objective-C actually does have a standard ABI, but come on, it's Objective-C. Yeah, advantages and disadvantages to that. But I think if you're, even if this talk, you didn't take anything, you don't care about PyGObject and all that other stuff, and you want to write kind of a binary project next, take a look at Vala. It actually has a lot of advantages over the other kind of object-oriented players in the field. So finally, the kind of wanton comparison here is Vala and Python. And it makes a lot of sense to use both. I mean, here's an example of a project where I wrote a logging library in Vala. Of course, I showed you the first example in C just to bug you. But I would probably write it in Vala and be able to interface with any C library I have very, very easily. And then immediately, quite easily, ship it with Python bindings, Ruby bindings, scheme bindings, anything that I want. So it makes a lot of sense to use both of them. At this point, Python can't export right, GObject. So that's, of course, the missing feature. Yeah, go ahead.
So, now I'm getting excited. So could you use, so before when I was saying, you could use Vala alongside some C stuff, I was thinking about applications, but does this mean that you could use Vala to write a portable application that would be compiled in C that through GObject introspect you could use in any language, basically, as a library?
Sure. Say you want people to develop plugins for your next application. So they can write plugins in any language they want. You expose the API once, and that's all you need. Or it doesn't have to be an application. It's very, very, I think, attractive for writing frameworks. So you want to write the next media framework that runs on toasters, but that anybody can use anywhere, right? So you write it in Vala, which is a pretty nice language. Has all the advanced features that you expect in all these languages, and then you can link it to anything and still get the C ABI. Yeah.
Where's the name from?
I don't know. I don't know why they called it Vala. And the very last point I'm going to make before opening it to question is Genie. So Genie is another language kind of like Vala. That is, it also compiles GObjectivec code in the background, does all the boilerplate code for you, but its syntax is based on Python. So it is pretty new. It's just 2 years old. There hasn't been a lot of, a lot of projects are being rewritten in Vala right now, especially because there's a nice path out of Mono. So if they wrote it in Mono before, converting to Vala is pretty easy. But for new projects, if you really want to be Python-centric, Genie could be very, very interesting. So the same Vala code that I showed you before, you would be able to write, this logging.vala, there would be a logging.genie, and the same thing. There will be there is a working Genie compiler that turns it into the C code. So for us Python folk, that's especially attractive. It's pretty young. Your mileage may vary. Actually, your mileage may vary with all of this. This is all pretty new. But wow, that's pretty neat. I'm hoping to get more involved in Genie and maybe give a presentation here in the future for it. Yeah, I haven't really played with Genie. I mean, it's really, you have to kind of compile it from scratch. It doesn't come with anything.
Genie talk next time.
Yes, I've explored it a little bit. And thank you.
We got some yummy cookies and stuff over by the end of the table. We're going to get ready for John and Chris. Up next.